Development Manager for Gates Australia, and I want to welcome you today to our webinar, which is all about water pumps, the engineerings and continuous improvements within the water pump range of Gates related product. So welcome aboard. We'll share the next close to an hour together. We'll have a bit of a deep dive into water pumps and what they do, what their function is, and why they're such an important part of the engine components that allow us to cool our engine to ensure that the engine operates effectively and efficiently. This is the fourth in a series of webinars that we're going to carry through to the end of 2020. Certainly an interesting topic today, but keep tuned for more interesting topics coming up in further webinars. They're going to be once a fortnight at this time on a Tuesday, so 12 noon Tuesday, Australian Eastern Standard Time. I want to welcome some friends and colleagues and customers over from New Zealand as well, who I believe are also have called in on this webinar. I'm going to start by saying I'm not an expert by any stretch of the imagination. I have seen my fair few water pumps in the industry, and I'm pretty well versed with what they do and how they operate, and I've seen one or two fail in my lifetime as well. So I'm not an expert, but if there is anything I cannot answer, if the question is too curly and it's beyond my level of expertise, I'm certainly happy to take it on board, and I will then rely on the resources of Gates, not only here in Australia, but globally, to help me through and get that response for you. So without further ado, I'm going to kick it off. Sit back. We'll take some questions at the end. If there's something I haven't covered or something that we need a bit more detail on, we'll wait until the end of this presentation. Please use the question and answers section on your screen there. Type them in and we'll get to them at the end. So let's kick it off. Today's presentation is going to be like this. We're going to talk about water pumps in general. We're going to talk about water pump design, and we really need to understand the mechanical water pump and how it's driven. Some are belt driven by the auxiliary belt drive, and some are indeed driven by the timing drive. And I've got a couple of examples there on that first slide. We're also keen to understand the components that drive the water pump, the complete drive system, all the other components that go together to be able to drive that water pump. And we're talking currently about mechanical water pumps. We'll touch on the water pump coolant in the system, and we'll also understand the components and construction. We'll dissect a water pump and we can have a look at the internal workings. We'll have a look at the critical role that a coolant will play within the system. We'll also dive a bit deeper into some of the technological improvements that water pumps have seen in recent years. We'll also touch on electric water pumps. That's fairly new to the marketplace and new in OE car manufacturing, but they've got a strong position in car making moving forward. What we strongly believe is that an informed customer is the start to reducing claims. So we want to share our technical knowledge and experience that we have on water pumps, not only here in Australia, but around the world, and particularly in the US, who do a very, very deep dive into water pump failures. So we'll touch on those further into the presentation, and we'll give you some do's and don'ts, and we'll even outline some typical failures that we see. It's important to understand that part of it as well. So next, we've got the system that drive the water pump. And typically, this is a mechanical system, and the water pump is typically driven by the drive belt. So we take the opportunity to talk about the complete system, the system as a whole, and we relay a message saying, be system smart. Do not look at one component in isolation. Take the opportunity to dive deeper into the components that drive all the accessories and understand the complete system and make the appropriate and confident recommendations to the vehicle owner. I think it's really important that we don't look at a water pump or a drive belt or a tensioner in isolation. This is a typical system that will drive that water pump. And regardless where the water pump is located in that engine layout, It's always the same. So there's our B System Smart message. You probably see that a hell of a lot at any Gates exhibition, or any time we talk about a complete system, we say B System Smart. So let's have a look at and dissect a water pump. And we've got a cutout there of a water pump, and we'll go through the internal components. And number one there is the impeller. And the impeller is there to drive fluid around the system. We've got seal rings, a dynamic seal, the spring within that seal. We've got a bearing that supports and it gives the ability for that system to drive. The spindle assembly, which is the long shaft which goes through the center of the bearing. We've got an outer bearing seal, an inner bearing seal, and a drain hole as well. And funnily enough, there are only two moving components in a water pump, and that's the bearing and the seal. They're the only two that physically have any sort of rotation. A water pump is designed for a very, very long service life. So if we have premature water pump failure, we really need to get to the bottom of what's causing that failure and address that before we move on. So in a pristine, well-maintained cooling system, the first component to fail within a water pump should be that bearing. And that bearing has probably got a typical lifespan where one day it will fail, and it will fail because of the moving components within that bearing. We've got balls, we've got raceways, we've got lubricant, we've got seals, all protecting the internal workings of that ball bearing. So the failure is typically due to the depletion of the lubricant within that bearing envelope. And avoiding any contamination within that bearing envelope, the lubrication will break down over time. Most belts today, well, most water pumps today are driven by the engine, either an accessory belt drive or indeed the timing belt drive. And the pulley that basically hangs on to the end of that water pump spindle. Now that spindle, we know, it rotates quite quickly. So whatever pulley's put onto the end of that spindle must be robust enough to be able to carry that load. So that's basically what the internal components of a water pump will look like. One of the most important areas to focus on, and we'll get to that a little bit later, is component number 9, the actual drain hole. And that provides a very important function to the water pump and the ability to be able to firstly lubricate the seal, but secondly drain away any lubricant that forces its way through. Let's look a little bit closer at the components, and we'll start with the pulley. The pulley basically turns the spindle, and that pulley's been driven by the power source. So in this case, in that picture there, it's an auxiliary drive belt, which is going to back idle against that pulley. So that the pulley connects the water pump to the power source. The second one is the spindle. And very simply, the spindle is effectively a fully sealed water pump bearing. And depending on the application, depending on the amount of power that we need to transmit through the drive system, that's why it was important to show you all the other drive components. Depending on the application and the amount of power we need to drive that system, that bearing can either be a double row of balls, it can be a ball and roller, or it can actually be a roller, depending on the combined load that we need to transmit. The seal is probably the most important part of this water pump, and effectively what it does is keep the wet area and the dry area separated. It's often called a dynamic seal, and it's often called a dynamic seal or mechanical seal to give it its correct terminology. And it works very, very differently to a standard lip seal, and I'll explain that in the upcoming slides. Gaskets are an important part. They give us an effective seal between the water pump body and the engine block or other mating components. Some water pumps now have a back housing, so it's essential and important that they're correctly sealed to one another. One thing is really important, and again, we'll touch on this in a little while, is some of the water pumps which don't have a gasket. So it's either sealed by an O-ring, which is recessed into a spigot or onto a groove, or indeed we use sealing paste. And it's crucial to apply the right amount of sealing paste. And we'll get to that a little bit later on. The impeller, there are two typical materials used for impeller. There's your standard, it can either be aluminium, it can be brass, it can be iron, or a new material that's been in circulation for a little while now. It's polyphenylene sulfide, or better known as PPS. And it is becoming more and more common in our marketplace today. So polyphenylene sulfide. Try saying that quickly. The advantages of a metal impeller, well, they're the traditional metals, cast iron, brass, folded steel. The advantages, they've got a really long service life, and they're actually really good for shock resistance as well. A disadvantage, they've got limitations to the amount of flow. With the PPS impeller, we can design the flow rate differently depending on what specifications we need and what cooling we need to flow around that system. The PPS certainly has some advantages. It allows for accurate flow rates. The design change can be minimal and we can get more flow going through that system according to what the specifications of the engine are. They can also be adapted to pretty complex designs. It's got a lifespan equivalent to metal, and it's usually used, or the makes and models we see it in commonly today are some of the more prestigious European ranges, including the VAG group, BMWs and even Mercedes-Benz. The disadvantage with a PPS impeller, they are vulnerable to shock loads, so they do not cope with them well. What we'll see if we put a PPS impeller through a shock load, we may see it crack in certain places. So it's really, really important that the right impeller is designed for the right application in the right vehicle. Let's touch a little bit now on some futuristic stuff or stuff we're actually seeing now in our marketplace, which is electric water pumps. And in the future, more engine will be equipped with an electric water pump, either as the main pump or an additional pump. We know with the evolution of hybrid vehicles and even electric vehicles, the cooling systems are becoming more and more complex. So an additional water pump to send cooling fluid around the vehicle is certainly something car manufacturers are using. The advantage of an electric water pump, it can be installed anywhere in the engine bay. It doesn't need to be aligned or associated with any external drive components, such as a timing belt or even the auxiliary drive belt. So there's maximum flexibility of where a car maker can actually tuck this little water pump in. And more often than not, they're in pretty difficult positions to get to. It does improve fuel efficiency, as an electric water pump will only be active when it's needed. So if the pump's not needed, it will be there idle. It's waiting for the electrical impulses from the engine management system to kick it into gear to send cooling fluid to part of the engine at a pre-specified temperature. So it's important to understand that as well. And the pump speed can be regulated independent of engine speed. And that's pretty important for cars with turbo units. Let's say the turbo unit needs to be cooled after the engine stops. After you've stopped, garaged the vehicle, taken the key out and gone inside, you'll typically hear the water pump continue to flow coolant through the system to ensure that the turbos are cooled. So a very interesting evolution of water pump going from mechanical to full-on electric. So next we're going to have a look at, and I mentioned earlier that water pumps are designed with a very, very long service life in mind. So if we believe we're replacing a water pump prematurely, we need to find the root cause of the failure. And it's got to be determined and fixed before replacing the water pump. And again, in a pristine, well-maintained system, the first component that we find in a water pump to fail is the bearing, due to that depletion of lubricant. And bearings are wear parts. They will age and wear over time. We normally don't see water pump failures attributed to a failed bearing. Actually, the percentage is very, very low. But in some aspect, it's good to see those failures because we can then assume that the water pump has reached its optimal life when we see an actual water pump failure. A water pump failure that's not due to external influences such as contamination. What we understand is most likely the failure is a result of a mechanical seal failure. So we've got a seal that's failed, that we're letting coolant through into the bearing area and indeed the bearing envelope. And I'll repeat, the role of the seal is to separate the wet zone from the dry. However, if excessive coolant gets through that seal and isn't dispersed out through the breather hole, we have potential to contaminate the bearing, and the fluid will get in past the lip seal of the bearing and into the bearing, which dilutes the grease, which pretty soon gives us contamination and a bearing failure. Our research show that more than 70% of failures are returned due to contamination of the mechanical seal. We'll explore that in the coming slides. And again, I'll stress, if you had a water pump failure, it's always important to understand why it failed and fix the cause first, not just supply and install a new water pump without trying to understand really the circumstances as to why that pump failed. This is one of the slides I borrowed from the US, and it's a very important slide because in the US, what they do is do a warranty claim sort. And they've done a sort every year since 2008. Actually, they do two sorts per year. Every year since 2008, and it's typically to understand what makes these things fail. Because when they fail, they can cause some catastrophic engine damage. So Gates USA researched to better understand why water pumps fail and the causes of these failures. And the information is used to educate the market and correct practices and problems that can cause a water pump failure. Our aim is to share this information with the general public and ensure that we train and educate the technicians that are actually fitting these components better. And we do this by producing things like technical bulletins, which are relayed directly to workshops and even our auto parts resellers in our marketplace. So that's what we do, and we're committed to doing this and committed to learning as much as we can about these failures and the different failure modes and what we see with the failures to better understand why these failures happen in the first place. Like I said, in excess of 70% are due to some sort of seal failure. But if a water pump's designed for a long service period, why is the seal failing prematurely? And we can put that down to a pretty important cause, which is contamination. So this next slide is the industry-wide problems. And when we do a sort of our warranty claims, we don't only look at the Gates manufactured pumps. We don't only look at the pumps that come out of our factories. We look at a wide variety of different pumps. And indeed, about 16% of all pumps, even though we may not have sold them through our distribution network, somehow come back to our distribution network and back to us for assessment. But we look at those as well. We don't draw the line. We look at those because it's important to include these pumps in the research so we can understand and compare Gates water pump failures with our competitor or even the OE water pump failures. It's an important part of what we do, so we continue to do it and have done every year since 2008. So I feel for the poor people doing these sorts, because as you can see there in that picture there, the water pumps, when they're returned, they're not in a great state. So now we're going to have a look a little bit more into some of the failures. And I'll start by stressing our warranty terms and conditions only cover manufacturing defects. So if you fit a Gates water pump and it is returned a few weeks or few months or a year or so later, and there is evidence of contamination or a seal failure or a cracked or broken housing or something like that that is identified as not being attributed to manufacturing or a process, the warranty claim, unfortunately, and I'm sad to say, will not be honoured. So it's important, and again, it's important to understand why the water pump failed and address that first before fitting a new pump. I'll do my best to walk you through some of these failures and some of the typical failure modes that we see, and highlight some of the really obvious issues. So on the screen there is just a pie chart. We reckon 73% of water pump failures are attributed to either a leaky, contaminated, or a failing seal. We've also put a squeaky seal in there because that can happen as well. And there's a couple of reasons for that. This is a typical mechanical seal configuration, and it's important to understand how this works. The seal is different to any standard lip seal. It does not strangle the shaft and have an interference fit on the shaft, strangle the shaft to provide the sealing. It works very, very differently. This mechanical seal is actually split into two. There is what we call a rotary side and a stationary piece. If you see here, this flange area is what goes into the water pump assembly. It has a spring that is in place. It has a spring that's in place, which gives it tension onto a sealing face. And the sealing actually occurs here, in this area here, between the mating faces of component A, which is the let's call it the sleeve, and the other piece here, which is the stationary piece here, which is that piece there. So the seal is actually press fit onto the bearing shaft and has a spring to ensure that consistent contact with the mating face. The faces are typically materials such as carbon and ceramic. And they use these materials because they're very, very hard wearing, and they're also very good at, being able to withstand contamination. But then they're not absolutely foolproof. If contamination does get through and score those surfaces, it will lead to premature seal failure. So typically the seal faces there as one side might be carbon, and in this side it's the stationary bit, which is carbon, and we've got a ceramic mating face on the part of the rotating seal cup, the seal cup. Other materials such as silicon carbide are also used, and silicon carbide can be more resilient to contamination. So in water pump with high failure rates, what we will find is, as a manufacturing improvement to the OE pump, we might indeed put in silicon carbide seals in place of a typical or a standard carbon ceramic seal. That seal dynamically can move along that shaft, minute increments, but it can move along that shaft. And that's why that spring is so important to keep that in place, because as temperatures fluctuate and the dynamic condition within that water pump can change, we need that seal to be adaptable. That's one of the reasons why they don't use a standard lip seal. Standard lip seals as well need some sort of lubrication to lubricate the sealing link. And it's typically an oil or a grease to lubricate it. We don't use either in this type of application. The actual sealing lip is lubricated by a small amount of coolant being able to pass through those two faces. So that's an important bit as well. So this is how it works. The dynamic seal rotates, and like I said, that area there is typically ceramic, and that rotates with the water pump, basically at the speed that the impeller would turn around. And the static part of the seal, and that's our spring, that yellow part of the seal there is our spring. The static spring is loaded to enable a constant pressure up against that mating face, so in this area here. A small amount of coolant, so we've got the wet side is on this side of the water pump, so that's where our impeller is around here. So a small amount of coolant is able to pass between those two faces, between the ceramic and the carbon face. And it works its way through the internal bit of the seal, so not touching the shaft, the spindle shaft or the bearing shaft. It comes in through a small gap, and it is able to purge out through the breather hole. Through the breather hole or the weep hole of the water pump, and it is a minute discharge. So if we've got excessive fluid coming out of that weep hole, we've got a problem with our water pump seal. It's allowing too much fluid through. So seal failures, there's typically 3 seal failure modes. We look at the first being a lack of coolant failure. Whoever would have thought that lack of coolant, but the seal must be lubricated. So if there is a lack of coolant coming into the seal will actually overheat. It'll take quite a bit of heat and energy to do that, but it is possible. The seal can leak. And look, it's not a catastrophic failure. You can probably get to that early and, fit a new pump and away you go. Contamination is a little bit more important to address and address that as early as we possibly can. And it can be contamination on that seal face can be due to abrasive components or material within the cooling fluid. And thirdly, the breakdown of the coolant can also leave deposits on the seal surface which lead to contamination. So typically a breakdown of coolant, the actual coolant fluid itself, which does wear over time, can contaminate a seal face. Let's look at the lack of coolant first. And if you've got if you've got any weep coming through the weep hole and you believe it's excessive, have a quick look at the overfill radiator bottle. Have a look there at the weep hole, what fluid's coming out of it and what colour that might indeed be. Does it look contaminated? And check the level within the overflow bottle. Is it at the right level? Is it low? And typically you'll see it low if we've got a lubricant issue on the seal. The seal will be burnt, and it's burnt due to overheating, due to the lack of coolant, and due to the lack of fluid passing between the two faces. In this instance, you must replace the water pump. You must replace the water pump and use the correct coolant when you're refilling. So that's probably our first. Probably not as typical a failure with the low coolant or lack of coolant coming in, because typically we see vehicles with a well-maintained, at least an adequate amount of coolant within their system. The next level is abrasive contamination, and that simply means that the particles floating around within the cooling fluid are harder than the seal surfaces or the seal mating ring surfaces, and they can be all sorts of stuff. And it happens when small particles dislodge internally. They could dislodge from radiators, heater cores, engine blocks. Even hard water or even normal tap water is used, that can lead to contaminants or hard particles working their way in between the seal face. Electrolysis is also a cause of this, and one of the key contributors to electrolysis is a breakdown of the cooling fluid. Cooling fluid does wear out and become less effective over time. So if we've lost the ability for that cooling fluid to protect the internal components of the engine, to adequately coat and protect those internal components, well, then we're going to have more particles floating around our cooling fluid. An abrasive contamination can actually cause wear to the impeller, and it can wear it down significantly, which will cause flow rate issues. You can compare contamination or this sort of abrasive contamination to sandblasting. Imagine the internal components within an engine being sandblasted by the floating contamination that's flowing around within that cooling system. And this leads us to the last one, which is the deposits on the seal surface ring. And they can become wedged between the seal mating surfaces, which again will create a problem. The failure depends on the sealing ring, consisting of contaminants which are softer than the seal ring. So they don't actually flow through the seal, they actually get in there and get stuck. So a small deposit will score the seal surface and propagate over time. If that surface of either the carbon or the ceramic mating face on that surface is scored, then it propagates over time. We'll get not only a weep coming out of that weep hole, but it will start to flow. And the first you might see is when you start getting a deposit of cooling fluid on the garage floor. Look for evidence of contamination in the system. Look for a dark colour in the cooler tank and inspect the fluid that's coming out of that weep hole. Is it clean or is it dirty and rusty, and does it look contaminated? Like that picture there on the bottom there, that's an obvious rust coming out of the weep hole, which I think on this water pump is in that area there. So the pump's almost orientated if you turn it 90 degrees clockwise, because you can see the flow of the rust just coming down the side of that water pump body. So very important to do your visual inspections to make sure that you understand, what the possibilities of why that seal has been damaged. Because from a technician point of view, they're going to just take that water pump out. They'll have a quick look at the impeller or the chamber where the impeller sits and assess that. And if that's rusty, well, then we've certainly got an issue with contamination throughout the whole system. So it's important to do your visual inspections. This is probably one of my favourite failures that we see, and we see this, we do see this occasionally, and it's cavitation. And cavitation is vacuum bubbles. It's bubbles that are created because there is more coolant exiting the water pump than what is entering the water pump. So it's cavitation can cause damage to metal surfaces, and as you see there in that graphic, it is and can be quite severe, and it really needs to be addressed. You don't see there's a lot of rust or anything on the impeller. It is purely cavitation caused by this pressure variation, and the pressure variation is that fluid going from the high to low pressure at very, very quick speeds, and it creates bubbles, and the bubbles are actually imploding, and they're breaking down the metal within that fluid, or they're breaking down the metal on the water pump as they come crashing into that area. So on this particular water pump, the fluid will be entering the water pump at sort of that 5 o'clock position, and it will be exiting through this position here. And that's where we find the fluid trying to race to that pressure point to equalise the pressure within that pump. Some of the key visuals that you might see or identifying factors, you do have contaminated fluid. You will also have a high vacuum reading on the suction line and a low discharge pressure on the high flow side of that water pump. So it's again, they can be some real key points to diagnose if your water pump is suffering from cavitation. One of the other things you'll hear, and you might need to do this with some sort of device that gets you listening closely to the water pump, like a stethoscope or the old screwdriver trick. Have a listen to areas around the water pump. It will actually sound like the water pump is trying to push stones through the system. There'll be a constant sort of rattle within that system, like the water pump is pushing stones. So one thing we've just got to be mindful of is the protection package, and this is the cooling fluid itself. And the danger of incompatible fluid. So failure, this type of failure is due to poor maintenance of the cooling system and or mixing of coolants. And the failure is poor interaction of coolants. You're mixing coolants that should not be mixed. They can lead to flow and erosion issues of the impeller. How to identify? We've got rust forming on the impeller. We've got flow rate issues as well. And this typically happens when it's a poorly maintained system. Remembering the coolant will break down over time. It will not last forever. And it's important to do not mix coolants. They can be incompatible. If in doubt, you must flush the whole system out. Flush it out and refresh it. I'm not going to tell you which type of coolant to use. I'm not here to do that. What I'm here to say is refresh the coolant, don't top up, refresh it with brand new coolant, and make sure it is the OEM recommended coolant that you put back in that system. That is critically important. So flush the system. Top left there is HOTE and OAT failure. That is a coolant failure, HOTE and OAT. And you can see there the water pump actually looks like it's been etched around that face. And this is a failure where we've mixed two incompatible coolants. HOTE is hybrid organic acid technology, and OAT is just plain organic acid technology. A lot of Asian vehicles use it. European don't. European don't typically use either of those. So we've got to make sure that it's the specific coolant for the vehicle as recommended by the vehicle manufacturer. The next one is suspended debris in the coolant, incompatible fluid again, weep hole leak. We saw that one before, cavitational protection package. If you replace a water pump and you see any of these types of failure modes or these characteristics on your water pump, replace it and ensure that you flush the system. And again, the water pump, the fluid within the system will deplete over time. It won't last forever, and the additives within that fluid will break down over time. So my key message there is if you've got anything that looks like that and you're doing a job on a water pump, whether you're a technician or whether you're one of the part sellers, one of our distributors out there in the field, ask the question, what's a water pump look like? Mate, you've got to flush and refresh that whole system. Don't just put a new pump on it, because you will just initiate the failure quite quickly yet again. Probably one of the parts that I need to bring to your attention, and again, I've pinched these slides from the US, so they call it misinstall. We'd call it something like incorrect install. But incorrect install are, again, a fairly high proportionate of bad installations. So we'll just cover a few, and we'll just cover a few of them. But I just want to make sure that we're on the same page, that we use the manufacturer's recommendations on the installation of these products, because they are a critical component within within the engine cooling system. It is the heart of the engine cooling system. The water pump is what allows that flow through the engine. Not only mechanical water pump, which we're all very used to, but the electric water pumps all do the same. So it's time to take a look at some incorrect installs, we're going to call it. The first one simply is casting brakes. And look, they could be as a result of overload. Now, we could have a faulty tensioner or some sort of faulty component within the engine drive system. Putting undue pressure on the casting within that water pump might actually break the casting. And casting breaks can also be caused by imbalance or overload, or imbalance of other associated components, such as a fan clutch or fan, You know, the old traditional engines, if you've got a fan that's out of balance, will put pressure directly on the next component, which would be that water pump. And we can see some pretty catastrophic damage there to those water pumps that purely just explode over time. And they're doing that because the bearing is in a rigid position. So if we're trying to get flexibility out of a double row bearing, well, guess what? You're just not going to get it. Flexibility within a double row, and that's why it's double row, to be as rigid as it possibly can, because we've got overhanging load. From one side, we've got a drive system, and on the other side, we've got an impeller that's pushing that fluid around the cooling system very, very quickly. So it's important that overload or tension is eliminated as a possible cause. So tensioner might be stuck in a position which doesn't allow tension. So your belt is going to get quite firm, and apply tension to the water pump pulley and components. Now, that water pump bearing itself might actually fail from being over tensioned before the casting breaks, and we'll see that evidence come out as a load within the raceways of that bearing. We'll see an abnormal load in the raceway of that bearing. Common misinstalls, another one. This is a good one, the use of silicon. We love silicon. No, we don't. Silicon on water pumps is bad. Okay. If the water pump is supplied with a metal or paper gasket or gasket material of whatever kind, there is no need for silicon on that water pump. If the water pump is supplied with an O-ring, there is no need for silicon on that water pump. So we see failures attributed to the use of silicon. We see many of them. You know, silicon, sealing paste, whatever you want to call it. The gasket is there to provide the adequate seal. And if we've got an overuse of silicon within that system, the silicon can work its way through the cooling system. And guess where it gets stuck? On the seal, on your mechanical seal inside your water pump. That's going to lead to a weep at first through the weep hole, and eventually enough fluid's going to come out, which will fail the bearing because it will get into the internal construction of that bearing and it will fail the bearing. So silicon is only to be used when there is no gasket or no O-ring supplied. And when we use silicon on the bare water pump where no gasket or O-ring is there, we use a minimal amount, a very, very minimal amount, just enough, a small, quick bead around the water pump flange, as minimal as you can possibly get away with, making sure all the surfaces are covered. But remember, when you torque that up against the mating components, that silicon is then going to provide an adequate seal. So the key message here is, if it's got a gasket or O-ring, no silicon. If you are needing to use silicon, so there is no gasket or O-ring present, a minimal amount is all that is needed. Do not do this. Do not do this. All we see is the silicon working its way into the internal water pump cavity and eventually working its way through the cooling system. Hopefully it doesn't get stuck in too many places, but it will work its way to the seal, to the mechanical seal, and cause a failure. Over torquing, we all get a bit ambitious on some of the nuts and bolts we do up, and it's really important to understand the OE specified torque. And it's there for a reason. It's there because that is the adequate tension that we've got to apply to that nut or bolt or to that fixture to ensure we get a nice positive fix and a nice consistent fix around the water pump. So over torque related failures are not that common, but we do see them and they're avoidable. They're certainly avoidable. So over torquing is very, very simple. Find the manufacturer's torque rating specification and use your torque wrench. Quite simple. And if you're not failing it right there at installation, you might actually crack it, and the water pump may fail some weeks or months later. Lastly, I think we've touched on this a little bit. during the course of this presentation is your bearing failure, but I've got a pretty good graphic where I can describe it. We've got your water pump, the wet side. So we've got your water pump and cavity and fluid flowing into this area here, which is your impeller. It will come in past that and it will make contact with your seal. The sealing face will allow a very, very small bit of lubricant to come through and then come out the weep hole. If it's any more significant than that, what we have is that coming in to the bearing. The bearings are housed in the unitized arrangement. And like you can see there, we've got in this particular diagram here, we've got a double row ball bearing. It's filled with grease. So the cavity of that bearing is filled with grease with seals on either side. We've got a standard lip seal and a standard lip seal there. That lip seal actually contacts the inner ring of that bearing. And that's there to keep the grease in and the water out. So coolant acts as the lubricant for the seal. And if there's any excessive lubricant working its way through there, eventually we'll get fluid coming in through a small gap there. Once it's through that small gap, the lubricant becomes less effective, and over time the lubricant becomes ineffective, and we end up with this. The seal pops out, the lubricant's gone, it's just a rusty mess inside. And more often than not, the bearing will just seize because of lack of lubrication. Lack of lubrication for any bearing or any precision product like a bearing is bad. Because when you have a lack of lubricant, you have increased temperatures within that envelope. Higher temperatures leads to metal expansion. So now all of a sudden, where we had clearance between the balls and the raceway of that bearing, we have a preload situation. So we've got additional load added to that bearing, more load than what we've got from the pulley on one side and the impeller on the opposite side. So all of a sudden now what we've got is a preloaded situation in a lubricant deprived bearing. You will get failure, and you will get failure pretty quickly. We're coming to the end now, but I can't leave this presentation without again addressing coolant. It's called the triangle of protection, and it offers things like corrosion inhibitors, anti-freeze, anti-boil characteristics. It is what we call the triangle protection, and it's there to protect the inside of your engine. It allows for a lower freezing point and a higher boiling point, and it's packed with corrosion inhibitors which coat the surfaces, the internal surfaces of the cooling system. And without that coating on those internal surfaces, we leave those surfaces subject to contamination. Contamination will lead to failure in some form or another. And it's a really important part of the system. If we don't have the right amount of protection package within our cooling fluid, it will break down and it will cause contamination. Compare the protection package inside your cooling fluid as the paint on the outside of your car. If your external surfaces of your car are not painted, they'll rust. And rust is bad. And rust is very, very bad on the internal part of a cooling system. So we need to ensure that our coolant's refreshed and adequately maintained in a really well-maintained cooling system. The coolant, it can be blue, yellow, green, pink, and it comes with, they all spruik their features and benefits. It's very simple in our eyes, and like I said before, I'm not going to make any recommendations in terms of coolant, what to use, what not to use, but I'm going to tell you it comes in various colours. And one thing I'm going to share, the colours internationally are not standardised. So where you might get a vehicle with yellow coolant in Europe, it might be equivalent to green coolant in Asia. So it is very, very confusing. Please use the manufacturer's stipulated coolant for your vehicle. You do not want to cause engine damage as a result of either filling or topping up with the incorrect fluid. So that's why we've got this little guy going, I just don't know. It's quite easy. Don't guess. Go back to the manufacturer's recommendations. Contamination of coolant is the presence of a component within that coolant that may reduce the effectiveness of the coolant and provide and failure to provide the adequate corrosion protection and the anti-freeze, anti-boil protection as well. Just 17% of intermixed coolant can cause a failure and can actually start that failure process. And it's only 1.3 litres in a 7.5 litre system. So if you're topping up, be very, very mindful to use the manufacturer's recommended coolant. Very, very important. What happens? The depletion of inhibitors, metal failure, build-up of rust, particles lodged between the water pump seal. It's all relative and it's all important to understand. Right back at the beginning of this presentation, I stressed, and I stressed it on more than one occasion, if we're replacing a component as critical as a water pump, have a look at the surrounding components and have a look at the condition of that water pump that's come out of that vehicle. Is it rusty? Is it contaminated? Is the impeller in good shape? Is the impeller being worn down? Do we suspect contamination within that cooling system? And if so, we need to find out the source of that contamination. We need to find out the source, the reason for it, why it's happening, and address it. And address it in a way that, that we fix that issue. And we fix that issue because the cooling system within any automotive vehicle is quite important. It's a very, very important system, and sometimes it's too frequently overlooked. So what we covered today, understanding water pump design, I think I did that over and over. We know the water pump is made up of some pretty critical components, and none more so than the actual seal and the bearing, the components that cause that or enable that impeller to rotate. The other ones there, obviously the pulleys that provide that power or attach to the power that's provided. We had a look at the belt drive system. The belt drive system, don't look at it in isolation. What was it? Be system smart. Have a look at the complete system. And I don't want you to only think of a cooling system. Think of any other system that you're repairing, that you're working on, that you're selling parts for, and ask the question around other components within that system. So be system smart. Be system smart and practice it in the workshop or on the sales counter as well. We looked at the water pump construction and the components within that water pumps. I stressed the role of the coolant, the protection package that it's got, and that protection package will deplete over time. It's really important. Technology improvements. We had a look at the impeller and the new PPS impeller designs and why they're being adopted. That's one of the technology improvements. The technology improvements of different sealing material within that mechanical seal. No longer your standard carbon ceramic setup. We're going to some of the more exotics like silicon carbide. Electric water pumps, they will become more and more popular as time goes on. They're adaptable, they're flexible, they work with the car manufacturers' ideas of smaller and more compact. The flexibility that gives them to install the water pump anywhere within that engine bay is a critical reason why they've gone with that. There's fuel saving improvements there as well. And, that the water pump's only active when it's needed, when it's needing to cool that system down. We've had a look at some of the inspecting and diagnosing things, and I've offered some suggestions on what to do if we've got some typical seal failures and how to diagnose them and look at them. And we've shown you some typical failures that we see, everything from excessive sealing paste to over-torqued bolts resulting in failures to water pump bodies. We've looked at some casting breaks due to impeller balance and so on. So I think today, we've been on the call for just on 55 minutes. I think we've covered all the topics within there. You will be able to a link to this presentation. We will shortly send out a link that enables us to review the presentation, or that link can then be shared with your colleagues or anyone else that you think might value and benefit from a presentation that we've done today on water pumps, or that might find it of interest and something they do want to share with their local colleagues and other workmates and so on. So now I'm going to open it up to questions. So if there's anyone with a question out there, I'm happy to answer the question. I've got Shane that says, "Great, Hi has been great in previous sessions as speaker." Thank you. So appreciate the feedback, good and bad. I mean, we're putting these webinars on as a forum to be able to educate, to be able to teach people, what we know. Because look, we've been doing this for some time, and we're working with the car manufacturers. And we're connected to these car manufacturers to design and develop these components as well. Okay, unfortunately, Shane's not had audio for some time, but I'm hoping he addressed that. That was a message early on. Okay, it looks like Shane's had the only question, and it does relate to his audio, or he's not been able to hear the audio of this. So if there's no further questions that you want addressed immediately, that's fine. If there is any further question, you can certainly contact me, available at Gates. You will get a link to this presentation. So again, you can share it. There is some upcoming webinars in a fortnight's time. We'll be looking at the heavy duty air brake system. So anyone there that's got a passion for heavy duty vehicles, we'll be taking a deeper dive into some of the components around the air brake system on large vehicles. So we'll be taking a fairly deep dive into that. Other than that, we'll see you again in a fortnight's time. Please share this if you need to, if you want to, that'll be great. If you've got any questions that you want to ask outside this forum, by all means, send me an email. You'll track me down at Gates. Only too happy to answer any questions that you might have. So thanks again. Thanks for sharing the last hour with me. I hope you got something out of it, and I hope that you bring back something either to your reseller counter and be confidently able to speak to technicians or customers about water pumps, what makes them work, why they're an important part of our system, and confidently be able to make recommendations on not only the water pump, but other components associated with that water pump. Bye all, bye from now. Thanks again, and we'll see you in a fortnight. Bye-bye.